This video presents some very important new findings which I have made concerning the famous Stonehenge site in England. Stonehenge has intrigued archaeologists and other researchers for centuries, and is still the subject of much speculation and debate as to its original purpose. When I first set out to make this video, I intended to focus on presenting my discovery of the Martian meter. I then intended to use Stonehenge as an example of how the Martian meter was likely used on planet Earth as a unit of measurement. However, when I examined Stonehenge in some detail, I made an amazing discovery which everyone seems to have missed. I found proof that Stonehenge makes extensive use of sacred geometry, and that this was likely an even more important reason for its construction than to have a structure aligned to the winter and summer solstices. I discovered that Stonehenge embeds a remarkable sequence of numbers from which values used in sacred geometry can be derived with astounding accuracy and abundance. But first, let's look at the Martian meter. Very few people have ever even heard of the existence of the Martian meter. This is a unit of length which I discovered a few years ago and have devoted a chapter to it in my book, Intelligent Mars 1, Sacred Geometry of the Mountains, Did Da Vinci Know? Evidence for the existence of the Martian meter comes from two sources. The first source is from a unit of measurement called the megalithic yard. The megalithic yard was postulated by Alexander Thom to be the unit of measurement used by the architects of the megalithic sites located throughout the British Isles, including Stonehenge. Using the measurements from over 200 stone circles in his 1967 book, Megalithic Sites in Britain, Thom estimated that the size of the megalithic yard was equal to 2.720 feet, with a standard error of 0.003 feet. I was curious to know whether the megalithic yard had any relationship to the radius of Mars. Hence, I multiplied Thom's value for the megalithic yard by 1,000 and converted this to kilometers, which works out to 0.8291 kilometers. I then divided the radius of Mars by Thom's value for 1,000 megalithic yards. The answer turned out to be 4096.24. Since Thom's value for the megalithic yard has only 4 significant digits, 4096.24 needs to be rounded down to an integer of 4 significant digits. In doing so, we get the number 4096, which is 1 followed by 12 zeros in the binary number system, and is exactly equal to 2 to the 12th power. Hence, I assumed that 1,000 of Thom's megalithic yards was actually an exact estimate to 4 significant digits of the radius of Mars divided by 2 to the 12th power. I therefore defined the Martian kilometer, abbreviated as MKM, as the radius of Mars divided by 4096 equals 0.29148 kilometers, and the Martian meter, abbreviated as MM, as 1,000th of this value, namely 0.829148 meters. You will notice that the first 4 digits of the Martian meter are exactly the same as the 4 digits of the megalithic yard converted to meters. Since the value of the radius of Mars has 6 significant digits, the value of the Martian meter also has 6 significant digits. The second source providing evidence of the Martian meter is from the remarkable formulae that are obtained when the distances to the moons of Mars, Phobos and Deimos, are expressed in terms of Martian kilometers. I found that each of the distances of these moons from the center of the planet could be expressed as integer multiples of 1,000 Martian kilometers multiplied by the square root of 2. Thus, Phobos is almost exactly 8,000 times the square root of 2 Martian kilometers, and Deimos 20,000 times the square root of 2 Martian kilometers from the center of Mars. NASA's measured values are no more than 0.05% different from these theoretical values. Since these meaningful values of the orbital distances could not possibly have happened by the random capture of asteroids by the planet Mars, the two moons could only have been artificially placed into their orbits. Hence, the Martian meter is indeed a standard unit of measurement that has been used on Mars, and it can be obtained directly from a physical standard, namely the radius of Mars. The validity of Alexander Thom's megalithic yard has come under attack in recent years by several investigators. The finding that it is identical to the Martian meter to 4 significant digits now vindicates Thom's claim that the megalithic yard was the standard of measurement used in the construction of megalithic sites in Great Britain. A good site to test the use of the Martian meter is the Stonehenge monument. Stonehenge is probably the most famous example of a stone circle on planet Earth. For most people, Stonehenge is a circle of giant upright stones which are capped by large horizontal stones called lintels, which connect the stones to each other. This circle is called the Sarsen circle, named after the type of stones used in its construction, which are made of silicified sandstone. It originally contained 30 upright stones. Inside the Sarsen circle, there are even bigger Sarsen stones, the trilithons, which consist of 5 pairs of upright stones, with each pair capped by a horizontal stone, that is, a lintel. The 5 pairs were arranged in a horseshoe pattern. Among the less well-known features of Stonehenge is the bluestone circle, which occurs between the Sarsen circle and the horseshoe construct of Sarsen stones. The bluestone circle is another circle of upright stones and is named after the bluestones used in its construction. There may have been 60 stones originally in this circle. From an accurate diagram of the Stonehenge site as viewed from above, we can see that in addition to the bluestone and Sarsen circles, there are 1. A circular ditch with banks on either side which enclose the entire site, 2. A circle of 56 holes or pits called the Aubrey holes, which likely held upright posts that were later removed, 3. A circle of 30 holes called the Y holes, and 4. A circle of 29 holes called the Z holes. The latter 2 sets of holes were thought to have been constructed to hold upright stones, but these were never erected. So in all, there are 8 concentric circles in the makeup of Stonehenge whose diameters can be estimated. The question to ask is, can these diameters be credibly fit to integer values of the Martian meter? The Martian meter is based on a very firmly established physical distance, namely the equatorial radius of Mars. We also know that it was used by an ancient civilization to measure out the desired radii of the orbits of the 2 moons of Mars, and it also exactly matches up to 4 significant digits the value for the megalithic yard determined by Thom for the diameters of a large number of terrestrial stone circles. I started out by trying to fit computer-constructed circles whose diameters had integer values of Martian meters to accurate diagrams of the Stonehenge site. I used the Plan 1 and Plan 2 diagrams which I just showed you from a downloaded copy of the book Stonehenge in its Landscape, 20th Century Excavations by Cleal, Walker, and Montague, 1995, which is provided by the Archaeological Data Service. I began with the outermost circle and worked my way inwards. The outer bank was very thin and irregular, so I simply tried to find a circle which followed the outside edge of the outer bank. A circle with a diameter of 141 Martian meters gave a very credible fit. Next, I calculated the average of 4 values from the literature for the diameter of the middle of the ditch surrounding the Stonehenge site. It came to 130.54 Martian meters. I used the value of 130 Martian meters for the diameter of this circle instead of 131, as it gave a better fit. 3 values from the literature gave an average of 116.85 Martian meters for the diameter of the middle of the inner bank, so I set its circle to a diameter of 117 Martian meters. Once again, a good fit was achieved. 3 values from the literature gave an average of 105.23 Martian meters for the diameter of the Aubrey holes, so I set the Aubrey hole circle diameter to 105 Martian meters. Cleo et al. Mentions single estimates for the diameters of the Y and Z holes, which I found to give circles which were too small to give credible fits, so I discarded them and came up with my own estimates from the drawing. I found a good fit for a circle of 65 Martian meters in diameter for the Y holes, and for a circle of 47 Martian meters in diameter for the Z holes. For the Sarsen circle, I calculated an average of 37.68 Martian meters for the diameter from 3 values taken from the literature. I set its circle diameter to 37 Martian meters since it gave a very credible fit, whereas 38 Martian meters proved to be too large. I could not find any estimates for the diameter of the bluestone circle from the literature. I found that a circle diameter of 29 Martian meters gave a credible fit for this circle. So, to summarize, the 8 concentric circles of Stonehenge are found to give credible fits to diameters which are integer multiples of the Martian meter. Most people would stop here and simply say that this exercise provides good evidence for the use of the Martian meter in the construction of Stonehenge. However, I was curious to see whether or not the ratios of these diameters produced meaningful numbers. After all, I found that for the Martian mountain Ulysses Tholis, the ratio of the area of its perimeter to the area of the perimeter of the caldera was equal to the number pi. If we consider only the ratios where the numerator is larger than the denominator, then the diameter of each circle can be the numerator for the diameters of all circles smaller than itself. Thus, the diameter of the outer bank can be the numerator for the ratios of the diameters of 7 circles. The diameter of the center of the ditch can be the numerator for the ratios of the diameters of 6 circles, and so on. The bluestone circle is the smallest circle, so its diameter cannot be the numerator for the diameter of any of the other circles. This produces a total of 28 ratios. What I discovered from this exercise is that the circle diameters in terms of Martian meters are not haphazard, but actually create a very interesting sequence of numbers. When ratios are formed, they are ratios of integers, and in many instances produce interval values which have been used in many systems of music throughout history. I found 7 such intervals for the Stonehenge sequence of circle diameters. The ratio of 10 is to 9 is known as a minor whole tone, and the ratio of 9 is to 5 is a minor seventh. The ratio of 2 is to 1 is the octave interval, and 3 is to 1 is the third harmonic. The other intervals are more esoteric music intervals, and I could not find names for them. This is the first indication that the circle diameter values have been chosen because of the numbers they produce when ratios of diameters are created. If we look at the ratio values for the Aubrey holes in terms of rational numbers, things get even more interesting. The ratio of the diameter of the Aubrey holes to the diameter of the Y holes is very close to the irrational number for the golden mean phi. That for the Z holes is close to the irrational number for the square root of 5. For the Sarsen circle, close to the value for twice the square root of 2. And for the bluestone circle, close to the value for the product of the golden mean and the square root of 5. Now, if we keep the diameter of the Aubrey holes constant at 105 Martian meters and adjust the diameter values of the other circles so that the ratios come out exactly for the irrational numbers to 6 decimal places, we find that the adjustments to the diameters are relatively minor, but we have to use 6 significant figures for the new diameters. We can now replace the irrational numbers by their symbols. The next thing to do is to investigate the ratios created by the new diameters when we use circles smaller than the Aubrey holes as numerators in the ratios. Incredibly, I found that these ratios are irrational number formulae accurate to about 6 decimal places, and I can now place their symbols in the table. How about the diameters of the circles larger than the Aubrey holes? If we examine the diameter ratios that they create with the bluestone circle, we find that they are close to irrational number formulae. For the ratio of the diameter of the outer bank to the diameter of the bluestone circle, we get the number 4.8585, which is close to the value of 4.8541, the number which is equal to 3 times the golden mean phi. For the ratio of the diameter of the center of the ditch to the diameter of the bluestone circle, we get the number 4.4795, which is close to the value of 4.4721, the number which is equal to 2 times the square root of 5. For the ratio of the diameter of the center of the inner bank to the diameter of the bluestone circle, we get the number 4.0315, which is close to the value of 4.0451, the number which is equal to 5 times the golden mean phi divided by 2. By adjusting the diameters of the 3 larger circles so that they produce the ratios of the exact values of the irrational number formulae to about 6 decimal places, we can then replace the rational numbers with the appropriate symbols for the irrational number formulae. Now, look at what happens to the rest of the table. The amazing thing is that music interval values and irrational number formulae accurate to about 6 decimal places exist for the ratios of the diameters of the 3 largest circles to the diameters of all the smaller circles. Thus, the entire table of 28 values contains music interval values and irrational number formulae for circle ratios accurate to about 6 decimal places. Let's now look at our table of irrational numbers. We see lots of occurrences for the irrational numbers of phi, square root of 5, and the square root of 2, but no occurrences for pi or the square root of 3. When I was experimenting with various circle diameters for the Sarsen circle, I noticed that one of the slightly larger diameters produced the value for pi for the ratio of the diameter of the center of the inner bank to the diameter of the Sarsen circle. Another diameter slightly larger than this produced the value of the square root of 3 for the ratio of the diameter of the y-holes to the diameter of the Sarsen circle. At first, I thought that only one of these diameters for the Sarsen circle must be the correct one. However, upon further reflection, it occurred to me that 3 diameter values rather than just one might have been intended for the Sarsen circle. The lintels of the Sarsen circle are about 3.3 feet wide, which would have been more than adequate to fit 3 diameter values of the circle, since the diameters differed by less than 1 foot. Upon using the diameter size required to produce the value of pi for the ratio of the diameter of the center of the inner bank to the diameter of the Sarsen circle, I was amazed to find that irrational number formulae with about 6 significant decimal places were produced for all circle ratios using the slightly larger Sarsen circle diameter as the denominator. In addition, the new ratio for the diameter of the Sarsen circle to the diameter of the bluestone circle was also an irrational number formula. All 7 of these new ratios contained the value of pi. Upon using the diameter size required to produce the value of square root of 3 for the ratio of the diameter of the y-holes to the diameter of the Sarsen circle, I was once again amazed to find that irrational number formulae with about 6 significant decimal places, were produced for all circle ratios using the larger sarsen circle diameter as the denominator. In addition, the new ratio for the diameter of the sarsen circle to the diameter of the bluestone circle was also an irrational number formula. All 7 of these new ratios contained the value of square root of 3. So now, we have a grand total of 42 music interval values and irrational number formulae for the 8 Stonehenge circles. What is so unusual about the circle diameter ratios is their incredible integration with each other. None of them are meaningless. All are found to be either irrational number formulae or music interval values, each accurate to about 6 decimal places. All of the irrational number components are found in sacred geometry. I have discovered that a similar emphasis on sacred geometry exists in the topography of Mars, in which the 6 irrational numbers of phi, e, pi, the square root of 2, the square root of 3, and the square root of 5 are hugely celebrated in coordinate values and distances between sites. All of these irrational numbers are present in the Stonehenge circle diameter ratios except Euler's number e. When we look at the frequency distribution of irrational numbers and integers used in the ratios, we find a heavy emphasis on phi and the square root of 5. Both of these numbers are found in the pentagram and are similarly emphasized on Mars. For the Stonehenge site, there is also a heavy emphasis on the integer 2, which is used mainly as a multiplier or a divisor. In sacred geometry, the circle is associated with the number pi. The equilateral triangle is associated with the numbers 3 and the square root of 3. The square is associated with the numbers 4 and the square root of 2. The pentagram with the numbers 5, phi, and the square root of 5, and the hexagram with the number 6. The divine creator uses these numbers and geometric shapes as building blocks of the universe. By honoring these numbers and shapes, Stonehenge and Mars honor the divine creator. But I believe that the architects of Mars and Stonehenge were not just honoring the creator, but were designing the structures to be in harmony with the cosmos which was constructed from these building blocks. In other words, by utilizing these numbers, the architects wanted their structures to resonate with and absorb the energy vibrations of the Creator, thereby bringing in healing energy and harmony to the inhabitants of Mars and to the visitors of Stonehenge. Indeed, archaeologists have suggested that Stonehenge was a center for healing, a prehistoric version of Lourdes that attracted the sick and injured. Researchers using DNA studies have determined that the ancestors of the people who built Stonehenge were farmers who came from the Aegean Sea area. This would link Stonehenge to ancient Greece. I have discovered structures on the surface of Mars that have the shape of symbols that are letters in the ancient Greek alphabet. This has been reported in my book, Intelligent Mars 3, Olm and the Architect. Hence, Greece may have been the source of the Martian meter used in the laying out of the Stonehenge site. Another major mystery to solve is that you would expect that the 8 Stonehenge circles, which create the matrix of sacred geometry numbers, would have been created simultaneously since they are so well integrated. This is in direct opposition to studies which place the construction of the ditch, outer and inner banks, and the Aubrey holes to about 3100 BC, the Sarsen Circle to about 2600 to 2400 BC, the Bluestone Circle from about 2280 BC to 1930 BC, and the Y and Z holes to about 1600 BC. Could it be that the 4 inner circles were constructed in rudimentary fashion at the same time as the 4 outer circles, and these were later covered over or replaced by the present 4 inner circles? Although it looks very much like the 8 circle diameters were measured out to conform to integer values of Martian meters, they had to be slightly adjusted to create a matrix of irrational number expressions. This is not unusual, as Thom had found that circle diameters were often adjusted from integer values so that the circle's circumference was a multiple of 2 1/2. It was obviously much more important to create the irrational number expressions than to have pure integer values for the circle diameters. So in conclusion, it looks like the principal purpose in creating Stonehenge was to have a site which would promote healing and internal harmony for its visitors by resonating with the cosmic vibrations created by a god who used irrational numbers and integers in the creation of the universe. The alignments with the winter and summer solstices would further connect the site to the sun as a vital source of energy. This discovery should perhaps cause us to reflect on the need for ourselves to be in harmony with the divine creator. Thank you for watching.